Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
In the annals of astronomical exploration, a peculiar tale unfolds, one beginning with frustration and ultimately leading to enduring fame. Picture Charles Messier, a diligent observer of the 18th century skies, tirelessly sweeping the heavens with his telescope. His quarry was elusive, transient, and highly prized comets. These celestial wanderers, harbingers of both wonder and, according to some, doom, held a particular fascination for the astronomers of the era. It was during one of these nightly vigils in the year 1758, while diligently hunting for these icy visitors, that Messier encountered a persistent anomaly in the constellation Taurus. This object, unlike the pinpoint stars that populated his charts, appeared as a faint, diffuse glow. It resembled, in its hazy appearance, a comet, a resemblance that initially sparked excitement. However, further observation revealed a crucial difference. This comet remained stubbornly fixed against the background stars. It did move, it did change, it was a celestial phantom, a cosmic impostor. This frustrating discovery marked the identification of what we recognize today as Messier 1, the Crab Nebula, the expanding remnant of a supernova explosion witnessed centuries earlier. This initial encounter encapsulates the driving force behind Messier's most enduring legacy. His ambition was straightforward: to discover comets. He sought to etch his name into the scientific record as a successful comet hunter, a goal very much in line with the astronomical pursuits of his time. The Messier Catalog, the collection of celestial objects that bears his name, emerged as a byproduct of this singular obsession. It was a carefully compiled list of troublesome fixed objects, nebulae, and star clusters that possessed the annoying habit of mimicking the appearance of comets in small telescopes. The catalog served as a practical tool, a celestial rogues gallery designed to prevent himself and other comet seekers from expending valuable time on these impostors. To fully appreciate Messier's work, it is essential to consider the astronomical landscape that preceded him. He stood on the shoulders of earlier observers who had diligently charted the heavens. The star catalog, compiled by John Flamsteed, the first astronomer royal at Greenwich, provided a fundamental reference for positional astronomy. Flamsteed's catalog, though primarily focused on stars, included some nebulae, influencing Messier's awareness of these extended objects. Edmund Halley's work on cometary orbits, particularly his successful prediction of the return of the comet that bears his name, served as a powerful inspiration and a model for comet hunters like Messier. Halley's successful application of Newtonian mechanics to predict the path of a comet demonstrated the power of mathematical astronomy. It fueled the desire to discover these celestial objects and the prestige associated with such discoveries. While Messier certainly consulted existing star charts and catalogs, his approach was distinctly his own. He did copy existing catalogs, he did improve upon them. Messier's methodology was characterized by its systematic and visual nature. He employed relatively small refracting telescopes, instruments that, while modest by modern standards, were well suited for the task of comet hunting. These telescopes, typically with apertures ranging from 3 to 6 inches, provided a wide field of view, enabling him to scan large swaths of the sky efficiently. He meticulously recorded the positions of the objects he observed, creating detailed descriptions of their appearance. He was a careful observer, a dedicated surveyor of the night sky. He relied heavily on visual observation, a skill honed through countless hours spent at the eyepiece. He lacked the sophisticated photographic or spectroscopic equipment available to later astronomers. His technique involved comparing the positions of observed objects with existing star charts. He would carefully measure their coordinates, noting their right ascension and declination, the celestial equivalents of longitude and latitude. Any object that appeared fuzzy or extended would be scrutinized. He would compare its appearance to known nebulae or star clusters. If it resembled a comet, he would monitor its position over several nights to determine if it exhibited the characteristic movement against the background stars. This painstaking process required patience, dedication, and a keen eye for detail. The essay will further explore Messier's successful discoveries of comets, detailing his methods for confirming their cometary nature and the tools he used for calculating their orbits. It will also examine the broader historical context of comet hunting in the 18th century, including the prizes awarded for such discoveries and the societal impact of these celestial events. Finally, it will delve into the lasting legacy of the Messier Catalog, tracing its evolution from a practical tool for comet hunters to a valuable resource for astronomers of all kinds. It is a story of perseverance, meticulous observation, and the unexpected path to astronomical immortality. Following his careful observation techniques, Messier's focus shifted to the pursuit of comets. His dedication and skill led to the discovery of several of these celestial wonders, solidifying his reputation as a prominent astronomer of his time. Each discovery involved a rigorous process of observation, verification, and calculation, demonstrating his commitment to precision and accuracy. Among Messier's successful finds was the comet C/1871070b1, also known as Lexell's Comet. This comet, discovered by 1770, proved particularly noteworthy due to its close approach to Earth. Its orbit was later calculated by Anders Johan Lexell, who determined it would pass remarkably close to our planet. The comet's proximity sparked considerable public interest and heightened anxieties about potential celestial collisions, a testament to the pervasive fascination with comets during this era. Another significant discovery was D/1871073T1, or Messier's Comet, found in 187-73. As with his other discoveries, Messier meticulously documented its position and movement, contributing valuable data for orbit determination. These observations were crucial for understanding the comet's path through the solar system and predicting its future trajectory, even though the comet itself was subsequently lost. Each observation was a data point, a piece of the puzzle contributing to a more complete understanding of celestial mechanics. Messier's methodology for confirming the cometary nature of a suspected object was methodical and thorough. He understood that a true comet would exhibit motion against the fixed backdrop of stars. Therefore, he would meticulously observe the object over several nights, sometimes weeks, charting its position with great care. He utilized calibrated reticles in his telescopes to measure the object's right ascension and declination, providing precise coordinates for subsequent analysis. This process distinguished comets from stationary nebulae or star clusters, which remained fixed in their relative positions. It was a process of elimination, confirming movement to reveal the comet's true nature. The calculation of cometary orbits during the 18th century represented a significant challenge. While Newtonian mechanics provided the theoretical framework, the practical application required considerable skill and computational effort. Messier relied on ephemeris tables, pre-calculated tables providing predicted positions of celestial objects at specific times to aid in his calculations. He combined these tables with his own observations to refine the orbital parameters of the comets he discovered. His understanding of Newtonian principles allowed him to interpret his observations and derive meaningful information about the comet's paths. Comet discovery held considerable importance in the 18th century, fueled by scientific curiosity and the potential for recognition. Several European academies and scientific societies offered prizes for the discovery of new comets, incentivizing astronomers to dedicate their time and resources to this pursuit. These prizes served as a form of patronage, supporting astronomical research and encouraging the systematic observation of the night sky. The pursuit of comets was therefore a competitive endeavor, driven by both scientific ambition and the allure of financial reward. The work of Edmund Halley exerted a considerable influence on Messier's comet hunting endeavors. Halley's successful prediction of the return of the comet, now bearing his name, based on Newtonian mechanics and historical observations, demonstrated the power of scientific prediction and sparked intense interest in cometary astronomy. Halley's work provided a concrete example of how comets could be understood and their future appearances predicted. This success motivated Messier and other astronomers to search for new comets and refine existing orbital calculations. Halley's legacy served as a constant inspiration, pushing Messier to contribute to the growing body of knowledge about these enigmatic celestial objects. The societal impact of comet discoveries in Messier's time was considerable. Comets were viewed with a mixture of awe, fascination, and apprehension. Their sudden appearances in the sky often sparked public excitement and speculation, sometimes fueled by superstitious beliefs and fears of impending doom. The scientific understanding of comets, advanced by astronomers like Messier, gradually replaced these superstitious notions with a more rational perspective. However, the public fascination with comets persisted, making comet discoveries newsworthy events that captured the attention of society. The discovery of Lexell's Comet in 1770, with its close approach to Earth, is a perfect example. The event triggered widespread discussion and even alarm. Newspapers and journals published articles about the comet, its orbit, and the potential consequences of a collision with Earth. While scientists reassured the public that the likelihood of such a collision was small, the event nonetheless demonstrated the power of comets to capture the public imagination and provoke both scientific inquiry and popular speculation. The comet became a talking point, a subject of both scientific debate and public conversation. Messier's meticulous observations and discoveries contributed significantly to the growing understanding of comets in the 18th century. His work provided valuable data for refining orbital calculations, testing Newtonian mechanics, and dispelling superstitious beliefs about these celestial objects. While he initially viewed comet hunting as a means to an end, a way to avoid confusing them with nebulae, his contributions to this field are undeniable. He diligently recorded the positions and movements of the comets he discovered, providing a valuable resource for future astronomers. His observations helped lay the groundwork for a more complete and accurate understanding of the nature and behavior of comets. The prizes offered for comet discovery further incentivized Messier's efforts. He secured recognition and financial support for his work through these awards, allowing him to continue his astronomical pursuits. These prizes were a tangible reward for his dedication and skill, acknowledging his contributions to the advancement of astronomical knowledge. They provided a practical means for him to sustain his research and contribute further to the field. Messier's dedication to comet hunting, driven by both scientific curiosity and the pursuit of recognition, ultimately led him to compile his famous catalog of nebulae and star clusters. This catalog, initially intended as a tool to avoid confusing these objects with comets, became his most enduring legacy, far surpassing his comet discoveries in its lasting impact on astronomy. It is a testament to the unpredictable nature of scientific discovery, where the pursuit of one goal can lead to unexpected and even more significant achievements. The catalog emerged from his comet hunting, a byproduct of his primary objective that ultimately overshadowed its original purpose. Messier's dedication to comet hunting, driven by both scientific curiosity and the pursuit of recognition, ultimately led him to compile his famous catalog of nebulae and star clusters. This catalog, initially intended as a tool to avoid confusing these objects with comets, became his most enduring legacy, far surpassing his comet discoveries in its lasting impact on astronomy. It is a testament to the unpredictable nature of scientific discovery, where the pursuit of one goal can lead to unexpected and even more significant achievements. The catalog emerged from his comet hunting, a byproduct of his primary objective that ultimately overshadowed its original purpose. The creation of the Messier Catalog was a meticulous process, born from the practical needs of a dedicated comet hunter. Messier, equipped with relatively modest instruments for his time, sought to distinguish genuine comets from stationary, diffuse objects that shared a similar appearance in his telescopes. The primary instrument utilized by Messier was a refracting telescope, typically with an aperture between 3 and 4 inches. These telescopes, while sufficient for spotting relatively bright comets, possessed limited light-gathering ability and resolving power compared to larger instruments available later. The small aperture affected the visibility of faint objects, making it difficult to discern their true nature. The chromatic aberration, a common issue with the refracting telescopes of that era, further complicated observations, producing colored fringes around bright objects, which could be misleading when observing faint, extended nebulae. The criteria for inclusion in the Messier Catalog were simple and pragmatic. Any extended, fuzzy object that could potentially be mistaken for a comet warranted inclusion. This meant that the catalog encompassed a diverse range of celestial objects, united primarily by their superficial resemblance to comets, through the limited resolution of Messier's telescopes. These objects included nebulae, both emission and reflection types, globular clusters, dense collections of stars gravitationally bound together, open clusters, looser groupings of stars born from the same molecular cloud, and galaxies, vast island universes, or beyond our own Milky Way. It is vital to reiterate that Messier's motivation was identification and avoidance, not a comprehensive astrophysical classification as understood today. The objects in the Messier Catalog were diverse. For instance, Messier 1, now known as the Crab Nebula, is a supernova remnant, the expanding debris cloud from a massive star that exploded centuries ago. Messier 45, the Pleiades, is an open cluster of young, Hiat stars easily visible to the naked eye under dark skies. Messier 13, the Great Globular Cluster in Hercules, is a dense sphere of hundreds of thousands of stars, one of the most prominent globular clusters in the northern sky. Messier 31, the Andromeda Galaxy, is a spiral galaxy similar to our own, but located millions of light years distant. These objects, while disparate in their true nature, share the characteristic of appearing as faint, diffuse patches of light through Messier's telescope, posing a potential source of confusion for comet hunters. The compilation of the Messier Catalog was in no way a solitary endeavor. Pierre Meching, a talented astronomer and surveyor, played a significant role in contributing to the catalog. Meching independently discovered several of the objects included in the catalog and communicated his findings to Messier. These include Messier 63, the Sunflower Galaxy, Messier 71, a globular cluster in Sagittarius, Messier 72, a globular cluster in Aquarius, Messier 75, a spiral galaxy in Pisces, Messier 75, a globular cluster in Sagittarius, Messier 76, the Little Dumbo Nebula, Messier 77, a spiral galaxy in Cetus, Messier 70, a reflection nebula at Orion, Messier 79, a globular cluster in Lepus, Messier 80, a globular cluster in Scorpius, Messier 81, Bogues Galaxy in Ursa Major, Messier 82, the Sigma Galaxy in Ursa Major, Messier 85, a lenticular galaxy in Coma Berenice, Messier 95, a spiral galaxy in Canes Venatusi, Messier 95, a barred spiral galaxy in Leo, Messier 96, a spiral galaxy in Leo, Messier 9, the Owl Nebulae Eraser Major, Messier 9, a spiral galaxy in Comet Berenice, Messier 99, a spiral galaxy in Comet Berenice, Messier 100, a spiral galaxy in Comet Berenices. Meiching's contributions significantly expanded the scope of the catalog and highlight the collaborative nature of astronomical research even in the 18th century. Messier readily acknowledged Meiching's discoveries, emphasizing the importance of shared observations in advancing astronomical knowledge. The Messier Catalog evolved through several editions, each reflecting the ongoing process of discovery and refinement. The initial version, published in 1771 in the Asterisk Memoirs de l'Académie Royale des Sciences, Asterisk, contained 45 objects. Subsequent editions expanded the catalog as Messier and Meiching continued their observations, adding newly discovered nebulae and star clusters. The final version of the catalog published during Messier's lifetime appeared in 1781 and contained 3 objects. This version represents the culmination of Messier's dedicated search for comet impulsors. The evolution of the catalog demonstrates the iterative nature of scientific inquiry, where initial observations lead to further investigation and a more complete understanding of the subject. The format and organization of the Messier Catalog were influenced by previous star catalogs, which provided a model for systematically recording and presenting astronomical observations. Flamsteed's star catalog, for example, served as a precedent for numbering and describing celestial objects. Messier adopted a similar approach, assigning a sequential number to each object in his catalog and providing a brief description of its appearance and location in the sky. He also included positional information such as right ascension and inclination, allowing other astronomers to easily locate the objects. This standardization of format facilitated the sharing of information and contributed to the development of a common language for describing celestial objects. The influence of earlier catalogs is evident in Messier's meticulous attention to detail and his commitment to providing accurate and reliable information to the astronomical community. The catalog structure, while simple, proved remarkably effective. Each entry typically included the Messier number, a brief description of the object's appearance, nebula without stars, cluster of stars, its position in right ascension and declination, and its apparent diameter. These details, though rudimentary by modern standards, were sufficient for comet hunters to quickly identify and dismiss potential false positives. The scientific value of the Messier Catalog in its time, the true scientific value of the Messier Catalog in its own era lies primarily in its utility as a finding aid for comet hunters. It was designed to be a practical tool, a means of rapidly distinguishing between genuine comets and the many nebulous objects that could be mistaken for them through the telescopes of the late 18th century. The catalog's purpose was efficiency in observation, allowing astronomers to quickly dismiss known objects and concentrate their limited observing time on the discovery of new comets. Its value resided in its ability to prevent wasted effort. Consider the laborious process of searching the skies for comets. Astronomers spent countless hours meticulously scanning the heavens, often under challenging conditions. The appearance of a faint, diffuse object could trigger excitement, potentially signaling the discovery of a new comet. However, many such objects turned out to be nebulae or star clusters already known to exist. Messier's catalog offered a means of eliminating these false positives quickly. By comparing the position and appearance of a suspected comet with the descriptions in the catalog, an astronomer could determine whether the object was already documented. This saved a substantial amount of time and allowed them to focus their attention on genuinely new discoveries. The catalog facilitated the efficient allocation of observing time, a precious resource in an era before automated telescopes and digital detectors. Observatories were expensive to operate, and astronomers were under pressure to produce results. Messier's catalog helped them to maximize their productivity by minimizing the time spent on unproductive searches. This was particularly important for astronomers who relied on visual observation, as the human eye is susceptible to fatigue and error. By reducing the number of false alarms, the catalog allowed astronomers to maintain their focus and improve the accuracy of their observations. Other astronomers utilized the Messier catalog extensively in their own searches and observations. For instance, Pierre Meiching, a close collaborator of Messier, contributed numerous objects to the catalog. These contributions highlight the collaborative aspect of astronomical research during this period. Meiching's observations, combined with those of Messier, created a more complete and reliable resource for the astronomical community. The catalog became a shared tool, enabling astronomers across Europe to coordinate their efforts and avoid duplication of labor. Despite its usefulness, the Messier catalog possessed inherent limitations due to the technology of the time. 18th century telescopes were relatively small and of limited resolving power. This meant that faint or distant objects could appear fuzzy and indistinct, making it difficult to distinguish between different types of nebulae or star clusters. Messier's descriptions were necessarily subjective, based on his visual impressions through the telescope. These descriptions, while helpful, lacked the precision and detail that would become possible with later advances in instrumentation. Furthermore, the catalog was incomplete. Messier's primary focus was on objects that could be mistaken for comets, so he did include all the deep sky objects visible through his telescope. Many faint galaxies and nebulae, particularly those located in the southern hemisphere, were omitted from the catalog. This limitation reflects the practical purpose of the catalog, which was to aid comet hunters rather than to provide a comprehensive survey of the heavens. The Messier Catalog should be viewed within the broader context of 18th century astronomy. This was a period of intense activity and rapid progress in the field. Astronomers were engaged in ambitious projects, such as the search for stellar parallax, which aimed to measure the distances to stars. They were also working to map the heavens, creating increasingly detailed catalogs of stars and nebulae. Messier's work contributed to these larger efforts by providing a valuable resource for identifying and characterizing celestial objects. The search for parallax, in particular, motivated much of the astronomical research of the time. Astronomers believed that if they could measure the apparent shift in the position of a star as the Earth orbited the Sun, they could determine its distance. This measurement was extremely difficult to make, as the parallax angles were very small. However, the potential reward, a better understanding of the scale of the universe, was immense. Messier's catalog aided in this search by providing a reference frame of fixed objects against which the positions of stars could be measured. Messier's work also contributed to the reduction of observational errors and the standardization of astronomical practice. By meticulously recording his observations and providing detailed descriptions of celestial objects, he helped to establish a common standard for astronomical research. His catalog provided a benchmark against which other astronomers could compare their own observations, allowing them to identify and correct errors. This standardization of practice was essential for the progress of astronomy, as it enabled astronomers to build upon each other's work and to collaborate more effectively. The influence of Messier's work can be seen in William Herschel's more extensive survey of the sky. Herschel, building on the foundation laid by Messier and others, embarked on a systematic search for nebulae and star clusters. He constructed larger and more powerful telescopes, enabling him to discover thousands of objects that were beyond the reach of Messier's instruments. Herschel's catalog, which contained many more objects than Messier's, became the standard reference for deep sky objects for many years. Herschel's work was demonstrably influenced by Messier's. Herschel recognized the value of a comprehensive catalog of nebulae and star clusters, and he sought to create a more complete and detailed version of Messier's work. He adopted a similar format for his catalog, providing descriptions, positions, and apparent sizes for each object. Herschel's success demonstrates the enduring legacy of Messier's catalog, which paved the way for more ambitious surveys of the heavens. The work of Caroline Herschel, William's sister, also shows the collaborative nature of astronomy at the time. In essence, the scientific value of the Messier Catalog during its time was predominantly practical. It served as an essential tool for comet hunters, enabling them to efficiently distinguish genuine comets from other celestial objects. The catalog facilitated the allocation of observing time, contributed to the standardization of astronomical practice, and influenced later surveys of the sky. While limited by the technology of the time, Messier's catalog played a crucial role in the advancement of astronomy during the 18th century. The enduring allure of the Messier catalog, particularly among amateur astronomers, stems from its accessibility. It presents a manageable compendium of deep sky wonders, a curated collection that provides a clear starting point for visual exploration of the cosmos. This selection of objects, ranging from nebulae to galaxies, offers a structured pathway for those beginning their journey into observational astronomy. The catalog's organization, based on readily determined positions in the sky, simplifies the task of locating and observing these celestial phenomena. This ease of access is a cornerstone of its continuing popularity. The Messier Marathon, a practice of observing all the Messier objects within a single night, exemplifies the catalog's appeal. This challenge, requiring meticulous planning and precise execution, transforms the catalog from a mere list into a framework for an engaging astronomical pursuit. The marathon fosters a sense of community among amateur astronomers who share their experiences and strategies. It transforms the catalog into a shared experience, a test of skill, and a celebration of the beauty of the universe. The marathon's existence testifies to the catalog's lasting impact, demonstrating how a practical tool can evolve into a source of recreational challenge and collective enthusiasm. The original intent behind Messier's work was eminently practical. His primary objective was to catalog objects that could be mistaken for comets, thereby streamlining comet hunting. His catalog was a tool, a means to an end. However, the modern application of the Messier Catalog differs significantly. While it continues to aid in comet detection, Its primary function today is to serve as an introduction to deep sky observation. Amateur astronomers utilize it to hone their observing skills, to familiarize themselves with the types of objects found in the universe, and to appreciate the vastness of the cosmos. This shift in function reflects the evolving landscape of astronomy, where the catalog has transitioned from a specialized instrument to a source of inspiration and education. The significance of Messier's work resides in its contribution to the history of astronomy, specifically in the transition from visual observation to modern astrophysics. The catalog, born from the limitations of 18th century observational techniques, provided a structured framework for understanding the cosmos. It helped to organize the chaotic variety of celestial objects, laying the groundwork for more comprehensive surveys and investigations. The catalog's impact extends beyond its immediate utility, fostering a systematic approach to astronomical observation. This systematic approach, the meticulous recording of positions and descriptions, set a standard for future astronomical catalogs. It demonstrated the value of detailed observation, a principle that would become central to the development of astrophysics. Messier's dedication to observation, his unwavering commitment to meticulously documenting the heavens, serves as an example for aspiring scientists. His work stands as a testament to the value of patience, perseverance, and attention to detail. He diligently recorded each object, its position, and its appearance. This meticulous approach, devoid of the glamour associated with grand theories or sweeping discoveries, enabled the creation of a lasting legacy. His dedication provides a model for scientific inquiry, emphasizing the importance of careful observation and rigorous documentation. While Messier did discover several comets, his primary focus was upon cataloging objects that were similar in appearance to comets. He did not, during his lifetime, directly discover planets or other major solar system bodies. However, his catalog indirectly contributed to their eventual discovery. By meticulously cataloging the positions of fixed stars and nebulae, Messier provided a reference framework. This framework allowed astronomers to distinguish between stationary objects and those that moved across the sky, such as planets. His work, therefore, provided a crucial foundation for future discoveries. It allowed astronomers to differentiate between the familiar and the unknown, between the static and the dynamic. The lasting impact of Messier's catalog arises from its unexpected influence. A tool created for a specific, practical purpose, comet hunting, has shaped amateur astronomy and contributed to a broader appreciation of the cosmos. His catalog, far from becoming obsolete, continues to serve as an entry point for those seeking to explore the universe. It fosters a sense of wonder, encouraging individuals to look beyond the confines of Earth and to contemplate the vastness of space. Messier's work, therefore, transcends its initial purpose. It is a bridge connecting the past with the present, allowing generations of astronomers to embark on their own individual journeys of discovery. The catalog's enduring appeal is also rooted in its inherent limitations. The catalog, constrained by the technology of its time, focuses on objects visible with the telescopes available during the 18th century. This limitation, paradoxically, enhances its value. The objects within the Messier catalog are, for the most part, accessible to amateur astronomers using relatively modest equipment. This accessibility ensures the catalog's continued relevance, allowing anyone with a telescope to experience the same awe that Messier felt while observing the heavens. The catalog is, therefore, a democratizing force, offering a shared experience of discovery. The catalog's legacy also resides in its influence on later astronomical surveys. William Herschel, for example, built upon Messier's work, extending the scope of his investigations. Herschel's catalogs, informed by Messier's methodology, expanded the range of known deep sky objects. His work, in turn, influenced the development of larger, more comprehensive catalogs that continue to be used today. The Messier catalog thus serves as a direct ancestor to modern astronomical catalogs, laying the groundwork for future exploration and discovery. It represents a pivotal moment in the history of astronomy, marking the expansion of our knowledge of the universe. The catalog's enduring value lies in its simplicity. It presents a curated selection of objects arranged in a manageable order. This simplicity is a key factor in its widespread adoption. It is a starting point, a guide for those new to astronomical observation. It is a framework for learning, a means of developing observational skills. It is a source of inspiration, a reminder of the beauty and wonder that awaits those who look up at the night sky. The Messier catalog, therefore, is more than a list of objects. It is a legacy. It is a testament to the power of observation, the enduring appeal of the cosmos, and the lasting impact of a single, dedicated individual.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.